So here's the blank again. I think it's too thick. We'll have to make that a bit thinner, I think, because I think it'll look silly. So perhaps that's the second thing we'll do. First thing, I've made 3 of these. The problem with brass is that I'll put it in the chuck and I'll tighten it up, and the chuck will tend to dent the brass, as it's probably just done there. You can see the dents, which will need more cleaning up and effort. So when we're working with brass or copper, we need these, which I've just made. They're made out of copper themselves, and they go onto the chuck key like this, the chuck teeth like this. There's 3 of them which fit on. That needs a bit tight, that one. And that gives us what we call a soft jaw, and that means that things can be gripped without them being dented by the hardened steel, sort of serrated. You can see the serrations in the jaw there, which tend to grip well but also dent softer metals. So that's the shoes made. So now we'll start with first of all, I think before I commit to making this thinner in this direction, I think I will machine one face to accept one coin slightly recessed, as discussed before, because if I stuff that up and I start doing it 2 or 3 times, it'll start working its way through the piece, and then I might find that if I've already cut it, that I've run out of stock. So I think I'll do that first, and then we'll take it from there. So this is the first penny machine, and you can see the little ledge in there to support the penny. You can probably see as well that the rebate is deeper than the penny, and the centre of this will get bored out eventually, but I probably want to keep sort of half of this for future projects, so I don't want to bore all the way through at this moment in time. But the penny fits reasonably well. It's not perfect, to be honest. I've overdone it a little bit. Not sure how that happened, but anyway. The brass around the outside, which is looking rough at the moment, will get machined back anyway in due course. So it doesn't matter that it's got marks on it. You can see the rebate there. That's so that when I do the soldering doesn't get all over this brass. I've got to think quite carefully about how I do the soldering, because there'll be a penny each side that'll want to be soldered in, and then there'll be fitments on and through the lighter that'll need to be soldered, and effectively when I heat it up they'll all become liquid at the same time. So I need to work out how things won't fall out and how things will be supported, and so on and so forth, and then having soldered in the bits that are going to stick out the top, how do I then put this back in the chuck with all those sticking out in order to machine this away. So there's a few things. So I'm soldering this down to size now. It's been a little bit tricky to clamp, as you can see, obvious reasons, but I'm hoping when this is done we'll have the lighter to approximately the right thickness. And we'll just see how that goes now. And now I'm using the hole saw to drill a hole. I could have drilled a hole and then used the boring bar. I'll probably use a boring bar to get it more accurate. But this is just going to take a big slug out the middle, and that slug I can be able to use in future projects. So just saving a bit of brass really by doing it with a hole saw. This will go right way through, and then it'll sort of give me the form of the thing. We now have a nut. There's a little nick in that corner, but that'll come out because that's got a deep rebate for the coins. George V coin. You can see the rebate there, which will get machined off eventually. You can see the little, yeah, that's the George V coin. And that's the Queen Victoria coin. And that's a little bit thinner than that, but that's about the thickness of the lighter. I'm keen not to inadvertently build a small petrol bomb, and so I thought I'd just test out the wick in a brass collet just to see how the thing works, make sure it doesn't burn back. As you can see, the whole thing's on fire. I don't know if that's because this open fuel is catching the same time as the wick, or whether the wick's burning back somehow. So I just need to do a slightly different test, I think. So this is the test where the wick is damp, and but you can see that it's not burning back through the brass and down into the wick, so I think that's good. Presumably the brass dissipates a bit of heat, and also the wick is configured to help with that as well. That all looks good. The wick is quite interesting actually. It's got an outer sort of woven fibre that is then somehow woven or wrapped with very, very thin copper wire, which allows it to keep its shape. But inside there's a core, which you can probably just see sticking out the top there. A core of sort of straight fibres, which presumably help to wick the fuel up. So yeah, quite an interesting little bit of design that on the wick. I've also noticed that the wick is really efficient. This is burned out at the moment, and it won't light, but I just dip the end in. It's not working for me. If I just dip the end of the wick in there, right on the end, you can now see that it lights straight away. So the wick is like really impressive, the way it transports the fuel up. The brass is a little bit warm, but not too hot to touch. So I think any heat will be transmitted back through the body very easily without warming up the fuel too much. Obviously, if it gets so warm that it vaporizes, then that could be dangerous, I guess. So we're cutting the cross T here. We're cutting the little rebate. To house the striker that contacts the flint. So I've made up this little test piece out of a bit of scrap brass. This thread was not by me, it's by the previous people. And I've put in the sort of striker wheel, and I can see that I need the gap here to be very much smaller, because the flint is only a tiny little flint. Problem is I've got these springs, but the smallest of them is actually slightly bigger diameter than the flint, which means that I want the hole for the flint to be as tight as possible for the flint, so that it doesn't waggle out and dislodge up at this end. So I've drilled a slightly wider hole up to here for the spring to go in, and it does appear that they won't, given a sufficient spring compression, there won't be any problem getting a spark. So this is what the cross section will look like. The flint is up here in the wheel, and I'll need a little transition piece so that the spring, which is a bigger diameter, can push on the flint So I need to make this little piece, a circular piece here. For the moment I've just used this bit of drill bit, but what problem is it actually falls down the inside of the spring, so I need to do some work on that, and I'll probably make that little piece out of brass as well. Otherwise though, this has given me some good insights into how to make this piece finally, and it looks like it probably will go okay as long as I take enough care on it. Obviously there'll be a screw, the drill bit will be taken by a screw which will thread into this side, I guess, in order that the wheel can be removable if it wears out. So this is my second attempt at cutting the flint holder. This is over diameter at the moment, possibly, but I've got it set up, and I've got this vertical vise set up, and this cutting tool. I've had to redo the arbor because it wasn't running straight last time, which meant that it was hard to position accurately in the center, and I've done that by using this micrometer attached so that I can get this rod in the middle of the center, hopefully. It wasn't running straight, and therefore it's hard to put it in the center, but now it is running pretty straight. And also, laterally it's pretty straight, and also it's not moving up and down vertically, it's pretty concentric. So so this will cut the slot. Having said that, it's a pretty severe test, but you can ensure that it's not actually running concentrically. It looks pretty good, but anyway, it'll be okay, I think, for this purpose. So I'll cut the slot, I'll move it in this direction, and then I'll move it up and down to make sure that it's not cutting a circular cut, and then that'll be the slot cut. Then I'll move this out and I'll cut a flat. Cut a flat on the outside here for the pin to go through, and this is a demonstration of all the milling type activities you can in fact do on the lathe with the right attachments and a bit of ingenuity. So I've cut the slot here using this device, which I think I've shown before. The mark there is where I think I need the axle for the flint striker wheel. And this next operation is that I've got a center drill set up exactly halfway by measuring to the top and the bottom and dividing by 2, and I've got it on the right way, and I've got a little bit off the mark because that is the minimum position I want the wheel, and I want a little gap under the wheel so that the spars can fly out, I guess. That's what I'm thinking. So now I will drill a cross hole of 2.5 millimeters diameter, and that will allow me to tap a hole for a 3 millimeter thread in one side. I've already used that, the boot wheel I used to cut the slot, I've used that to cut a flat in each side, just to save me having to round off the pin. The pin can have flat ends if there's a flat at each side, which there is, and you can see I've just started drilling the hole there, which does look to be central, should be central, and that'll be the next operation. I'm keeping everything in place, and I'm not taking this out of the vise at all, so that I can make everything as accurate as possible whilst it's in there. As soon as you take it out, it's hard to get it all back in exactly the same place. I will also then use the chuck to hold the tap so that the tap comes through perfectly perpendicularly. So I've drilled a 2.5 millimeter hole all the way through, and now I'm putting some tension on the long feed to push the brass into this cutter, which I'm just turning the chuck by hand to put the cutter in and make sure that it's exactly perpendicular, and that it will cut through here exactly horizontally. There'll be a thread in this side on the stainless steel pin, but I don't want the wheel to sit on a thread. But fortunately this pin is bigger than the hole, so I'll be able to turn down part of the thread so that it's smooth for the striking wheel to go on. The striking wheel hole is 2.5 millimeters, whereas the bolt that will go through will be a 3 millimeter bolt. I've now done a first run of the axle there, the wheel holder and the tube. They're all thicker than they're going to end up, because I like to leave plenty of meat on at the moment, so that I can you can always take material away easier than you can add it, basically. So there's the wick in its holder. I've got a scrap piece of brass here, and I've drilled 2 holes in it. You can see one hole puts the wheel quite away from the wick as it is now. That's the maximum distance I could attain without coming off the flat on the hexagon. And the other hole here is as close physically as I can get to the wick. And this, you can't, it's not easy to see on video, but this is producing sparks with my temporary setter. And I'll dip the wick in some fluid underneath and just check that this sort of height works. I could reduce the height of both if I want, it depends how it looks on the lighter. We'll have a look later. Just to see that this works at this height. Might be able to reduce the height of the wheel a bit, I think, but we'll see. So here we have the test rig in the most furthest position away to see if it can work. And there we've got the wick in some lighter fuel. Hopefully the whole thing won't go up. So let's have a look. The spark is actually struggling, I think, to reach the wick. So this is the rig. This is with the striker as close as it can be to the wick. And there's the wick sitting in some lighter fuel. The sparks are working well. So there we have a nice flame. The trouble is, it is very close, and it is actually licking around the wheel, which is not ideal.